we look at an equilateral triangle, an equilateral triangle is one that has all three sides the same length. And we know from geometry that if we have an equilateral triangle, that the three angles are also going to be equal, and that they have to be 60 degrees. This angle has to be 60 degrees, and so do the other two angles, as long as all three sides of the triangle are the same length. Now, if I take this equilateral triangle, and I find the midpoint of the base here, right where the middle is, and I cut a line up through the triangle, I'm going to divide this angle equally in half. And so this angle will be 30 degrees, right? And this angle over here is also 30 degrees. And so I'm going to say, let's say that the length of this side of the triangle was 2, okay? And I'm picking 2 because when I cut this side in half, this side will be 1, right? So for this triangle, the length of this side will be 1, this one will have to be 2. Right, because all three sides were supposed to be equal to begin with, and if I cut this one in half, it has to be half of what that side is. And when I cut this triangle in half, I should also point out that finding the middle point and bisecting this angle guarantees that I have a right angle here. And so this is a right triangle. The hypotenuse of this triangle is 2. One of the sides of the triangle is 1, and the third side, I'm not sure yet what the length of that side is. And so Pythagorean theorem says that the hypotenuse squared is equal to the sum of the squares of the other two sides. And so if I let this be angle A, this is angle B, this is angle C. For this triangle, this will be side A, and this will be side B, and this will be side C. And so I already know sides B and C. I'm looking for side A. And so I'm going to subtract B squared from both sides. Okay, and I'm going to take the square root of both sides. And so A will be equal to the square root of C squared minus B squared. And we've seen this form of the Pythagorean theorem before. And so C squared is 2, so that would be 2 squared minus B, which is 1, and that is also squared. And so A will be equal to the square root of 4 minus 1, and A will be equal to the square root of 3. And so I'm going to leave this as a radical. The length of this side is radical 3. Okay. And so now we can look at the angles. We know that the angles are 60 and 30 degrees, and we know the lengths of the three sides of this triangle. And so we can find the sine of 60 degrees in an exact form. So the sine of 60 degrees is going to be the length of the opposite side divided by the length of the hypotenuse, right? And so the opposite side is the square root of 3. The hypotenuse is 2. And the cosine of 60 degrees will be the adjacent over the hypotenuse, so that's 1/2. The tangent of 60 degrees will be the opposite over the adjacent, so that's the square root of 3 over 1, which is just the square root of 3. Cotangent of 60 will be this reciprocal, which would be 1 over the square root of 3, but we don't really like having radicals in the denominator. And the way we get rid of that radical is to multiply the numerator and the denominator both by that radical. And when I do that, 1 times radical 3 is radical 3, and radical 3 times radical 3 is radical 3 squared, and squaring a radical cancels out the radical. So radical 3 times radical 3 is just 3. When you square a radical, the radical goes away, and you're just left with the argument of that radical. And so the secant of 60 degrees will be the reciprocal of cosine, which is 2 over 1, which is just 2. And the cosecant of 60 degrees will be the reciprocal of the sine, which will be 2 over radical 3. And again, I don't want the radical 3 in the denominator, so I multiply numerator and denominator by radical 3. And in the numerator, we get 2 radical 3. And in the denominator, again, the radical cancels, and we get 3. And so these are the exact values of the sine, the cosine, the tangent, the cotangent, the secant, and the cosecant of 60 degrees. These are the exact values. And we could do the same thing for 30 degrees. The sine of 30 degrees, so for 30 degrees, that would be the opposite over the hypotenuse. It's going to be 1/2. And of course, if you remember, the sine of one of the angles in the triangle is equal to the cosine of the other angle. And so these are equal. And the cosine of 30 degrees is going to be the adjacent over the hypotenuse. So that is the square root of 3 over 2. And again, that is equal to the sine of the other angle. And the tangent of 30 degrees is going to be equal to the cotangent of 60, which is radical 3 over 3. And the cotangent of 30 degrees is going to be equal to the tangent of 60 degrees, which is radical 3. And the secant of 30 degrees is the same as the cosecant of 60, so that'll be 2 radical 3 divided by 3. And the cosecant of 30 degrees will be equal to the secant of 60 degrees, which is 2. And so again, I have the exact values of the sine, cosine, tangent, cotangent, secant, and cosecant of 30 degrees, and also for those same 6 trigonometric ratios of 60 degrees. I have the exact values. And so we call this a special triangle. The special triangle is this particular one is a 30 degree, 60 degree, 90 degree triangle. And so with a 30, 60, 90 degree triangle, the ratio of the sides are 2 to 1 to the square root of 3, just like we had here. And we can determine the exact values of the trigonometric ratios of 60 degrees and 30 degrees for this special triangle.